Hello students, welcome to Legacy IAS Academy. In today's video, we are going to discuss about glacial landform development, and we are going to focus upon such landform that develops or forms due to the erosional action of the glacial movement. So let us try to understand this topic in more detail. So first of all, if we talk about the glaciated landform that has developed on the Earth's surface, most of them can be traced back to the Pleistocene period. It was the period that lasted somewhere between 2 million years ago from now up to 10,000 years past. And it is during this epoch, we can say, in the earlier half of the Quaternary period, when you have widespread glacial ice that is covering a large part of the Earth's area, and that also marks the advent of the modern human on the Earth. If we talk about glaciers, this can be simply described as a very huge, large masses of the ice, and the landforms can be found in such locations where even today, glacial landforms can be found in such locations where currently you will not see any active glaciers or any active glaciation process. So these all glacial landforms can be traced back to the older period, which was the last ice age in the history of Earth. So obviously, if someone asks you that which parts of the earth you can find glaciers, two areas will come into your mind. First of all, in the higher latitudes in the polar environment, such as in the Antarctic region in the southern hemisphere and the Arctic region in the northern hemisphere, you have large sheets, large masses of the moving ice or glaciers. Apart from that, glaciers are also found on the high altitude mountain environment. For example, if we talk about Himalayas, we have numerous glaciers in the Himalayas and Trans-Himalayas, most notable being Siachen Glacier, which is also considered as the highest battlefield of the world. So it is in these two environments, when the glaciers start to move or begin to move, we see the development of erosional landform due to their action. Now, this is a map that describes the development, the expanse of continental glacial sheets during the Pleistocene epoch, and you can see the entire part in the northern hemisphere, for example, extending all the way up to the Canada or border of US and Canada in the north, and in Eurasia we have the large part of Europe and large part of Asia, Russia and Central Asia is being covered by the glacier. Similarly, if we talk about around India, due to the presence of Himalayas and Trans-Himalayas, this mountainous area also has large-scale glacial movement. So it is due to this movement of glaciers in this region, glacial landforms have basically developed. So the question comes that what action of glacier lead to development of erosional landform? So what we can basically say that such glacial landforms develop due to the process of accumulation and compaction of recrystallized melted snow that is part of glaciers. And if such landforms are developing in high latitude polar environment, these glacial movements or the glacial sheets are called as ice sheets or simply also described as continental glaciers. On the other hand, if glacial movement is happening in the high altitude mountain environment, such glacials are described as alpine glaciers or simply as valley glaciers. Glacial processes produce a combination of constructive, which we can say erosion, depositional, as well as destructive landform, which we can call also as an erosional landform. The process of erosion occurs via two major methods. The first of all is what we can call as a plucking. Plucking is something when we have suppose a glacial that is moving on the downslope region. So as the glacial moves over the downslope region, what happens? The pressure suddenly decreases. And as the pressure suddenly decreases, what it causes? It causes the freezing up of the water. And as the water freezes up here, and then it is pulled along with the glacial sheet, and this is called break in the rocks, break in the particular structure. So this is what we can call as plucking. It gives rise to a serrated or very kind of rugged kind of edge, rugged kind of landform. On the other hand, we have abrasion process. Abrasion is the movement of glacier when pressure suddenly is very, very higher, and due to this high pressure, what happens? The glacial, the bottom of glacial gradually convert into the form of water, and thus there is a smooth movement of glacial that happens over this particular surface. And due to this, what we see, a polishing of the surface basically happens, and also to some extent erosion happens, which we can call as abrasion. So it is due to the method of abrasion and plucking we see the development of erosional features in the highland region of the glaciers and also depositional feature on the lowland region of the glaciers. So the first important erosional landform which we have to talk about today is U-shaped valley. Now these are valleys which are very, very peculiar to the movement of glaciers, because if you remember the fluvial landform, there we have discussed that due to the movement of rivers in the hilly areas, mountainous area, the shape of valley that develops there is kind of V shape, which is broader at the top and very narrow at the bottom. On the other hand, glaciated valleys are U-shape in cross section. However, they have very steep and straight sides. If you look at this particular picture, you can clearly see this is a U-shaped valley, and on both sides of this valley, a very steep kind of slope, which with a flat and rounded bottom kind of characteristic you will observe here. The Utes Valley generally forms when the glacier travels across down the slope and the scarf the valley by the action of scouring. A scouring here refers to the erosion that happens on the valley bed or on the rock bed due to the movement of glacial and the sediments embedded in the glacier. And as glacials, many times what happened earlier, you can suppose that there was a V-shaped valley here that was formed by the river. But when the temperature of Earth started to decrease, what happens? The river will then start to freeze, and thus will have generation of glacier in these areas. And as glaciers move from the upper part of mountain to this valley areas, this V-shaped valleys that has been earlier formed by river, they start the glaciers start to do the erosive actions on the bottom of these valleys, and as the erosive action progresses on the bottom of valley, gradually it causes enlargement of the valley bottom and thus give it a characteristic U shape, and this it has an over steepening of the wall that we can see will happen here, and thus the steep slope with a U-shaped bottom kind of valley develops due to the movement of glaciers. Around this U-shaped valley, you will also find several valleys which are called as hanging valleys. The reason behind hanging valley is simple, because if you look at this particular picture, you can see that this is your main valley, which is a U-shaped valley, and this another small valley seems to be hanging above this main valley, and that is why it is called as hanging valley. Hanging valley is believed to be a remnant of confluence between tributary glaciers and valley glaciers. Suppose if a large glacier is moving in this particular area, so obviously since the mass of ice sheets present in this glacier is quite higher, the extent of erosion caused by this main glacier will also be quite higher. Thus, the subsidiary glaciers which are having less volume of ice, they are not able to keep up with the extent of erosion which this main glacier is contributing to. And thus what happens, there is a steepening of valley that happens at a much more greater extent by the main glaciers, and then the surrounding smaller glaciers are not able to erode to that extent, and thus what happens, we see a development of a hanging kind of valley structure develops. And many times when you have suppose temperature rises, this glacial can the ice of glacier can melt, and thus you can also have a waterfall like feature that will develop, that will seem to be coming from this hanging valley to the main valleys. Many times what happens, water gets accumulated here and there during the warming phase of the earth, and thus also have formation of lake like feature in the main valleys or U-shaped valleys of the glaciers. And then you have the waterfall, you have the different lakes are there, and then also you have the river streams that are moving in the U-shaped valley. Most of the time, hanging valleys are also used as a natural head of water for generating hydroelectric power, because since they're coming from a higher elevation, higher height, their kinetic energy, the water's kinetic energy can be transformed to generate hydroelectric power, and that is why also this is very important from economic point of view. So overall, if you look at any glaciated regions, especially the mountainous region, this is what kind of a structure you will find across here, because this is your main valley, which is deeply eroded. And from surrounding areas, you have a small glaciers are there, having a small amount or small volume of ice carrying glaciers are there. They are not able to erode to that much depth, and that is why it seems that a lot of valleys are hanging above these main valleys. And as you can see, as the warming phase earth enter into warming phase, we can see the movement of this water from this hanging valley, which is falling down in the form of waterfall. This is one example of waterfall in the Glacier National Park of Montana, California. This is the example of a hanging valley. This is the main valley, which you can see is currently occupied by large scale vegetation, dense vegetation, and thus this waterfall is example of hanging valley water. The third and one of the most important landform that develops in the glaciated region is what we can call as Cirques, or as called as Corrie in the Scotland region. This is simply an armchair shaped steep wall depression that represents a glaciated valley head. And what happens, many times it also takes a bowl kind of shape. It is heavily eroded, and it's kind of depressed feature that develops near the top ridges of mountain, where we have snow accumulation at the head of alpine glacier. Now, as the glaciers start to move through this valley head, through the alpine head region, due to the downslope movement of glacier, it scours the bottom of this mountain. And as the bottom of the mountain is scoured, what happens? A kind of, we can say, a depressed feature will develop here, and this is something that we can call as Cirques and Corrie. Also, what you will see, and other important feature in the Cirque region is what we can call as Bergstrand. Bergstrand refer to that vertical kind of cliff that develops due to the vertical break of the ice sheet, vertical break of glacier from the accumulated snow in the valley head regions. So as we can see, what happens as glaciers start to move in the downslope areas, there is less amount of snow available here, and that is why this part is not able to keep up, and thus suddenly we have a vertical break that is observed here. So we have Bergstrand. Many times what will happen if the warming occurs in these areas, then obviously the ice of glacier will melt into the water, and this will also have several lakes that will develop in these Cirques and Corries, which are called as Corrie Lake, or sometimes it is also referred by the other name of Tarn Lake. So Tarn Lake develops in the Corrie region of the mountain. If you look at the picture here to make it more clear, this is how a Corrie look like. As you can see, all across this area you have the mountain peaks are there, and as the glacier must have moved from this area and then had moved in the downslope region, what it has caused erosion of these areas, and thus we have development of the corries. And if it is we have a snow accumulation that happens here, then it is called as cirque glaciers. Now, related to the cirques and corries, we have three another important landform that develops in the upper part of the mountains, that is called as Arêtes, cols, and horns. So let us try to understand each of these in details. Arêtes, as you can see, this part of the mountain is what we can call as Arêtes. So they are simply, as we can see, they are having this zigzag kind of tooth. If you look at the top of Arêtes, this is how they look like. So these are sawtooth, zigzag tooth. Ridges are serrated in nature in the glacial mountains, and basically if you look at, this is one arete. So what it is doing, it is separating two different cauries. As you can see, the glacial is moving in the downslope area. It has scoured this particular region, formed a depression, and there I told you that lake will sometime develop, which is called as Tarn Lake. Here you have Corrie, here you have Tarn Lake, and the separating these two corries or separating these two cirques is you have Arêtes, that is a sawtooth kind of ridge. Now, what happens sometimes is when two cirque basins are on the opposite side of mountain, when they start to erode the Arêtes, then it divides them, and thus a saddle-like structure is created, or we can say a pass kind of mountain pass is created over the mountain, which is called as cols. Now, imagine that if you have three different corries causing headward erosion from three different sides. One corrie is causing erosion from this side, other corrie is causing erosion from this side, and we have another corrie on the back side of the mountain in this particular picture, which is causing erosion from the other side. So due to this continuous headward erosion by these three corrie glaciers, what will happen? A kind of pyramidal peak, pyramidal conical structure will develop, and this pyramidal peak like structure is referred as horns. And thus we can define what are horns. Horns are a single pyramidal peak that forms when the summit is eroded by the cirque basins on all the sides of the mountain. And one of the most notable horn we have is Matterhorn, that is present in the Alps mountain of Switzerland. This is, you can see, this is how the horn look like. If you can imagine, this side must have been another Corrie or Cirque. On the other side, we have another Corrie and Cirque. Then on the back side of the mountain, also we have another Corrie and Cirque. And due to continuous headward erosion, this kind of pyramidal peak-like structure had developed. Overall, if you look at the mountainous areas in the upper part of the mountain, all the three structures such as horns, cols, arêtes, and corries you can find. For example, this picture has been taken from Chugach mountain of Alaska, and here we can see this is your arêtes. As we discussed, this is kind of serrated kind of sawtooth edges is there, which is separating two corries. On one side we have one corrie, this side we have another corrie or cirque. Similarly, we have a col, that is a kind of depressed feature develops due to continuous erosion, and then we have the horn that has developed due to continuous erosion, headward erosion by corries from three sides. Thus horn, col, arêtes, and cirques are the major feature of the upper part of mountain. Now, another interesting landform that develops in the glaciated region is what we can refer as NUNATAK. NUNATAK is nothing but these are higher peaks and mounts which seem to be which actually is surrounded by ice from all the sides. And that is why if you look at the top view, they seem like scattered small island surrounded by ice from all the sides, and that is why these are also called as glacial island. These are features which develops due to large scale movement of the ice or glacier, especially when the earth is in the cooling phase. Then we have the next important landform that develops due to erosional work of glacier is what we can refer as Paternoster Lake. Paternoster Lake occurs in a kind of series down a formerly glaciated valley in small basins which is scooped out of the glacier as it retreats. The name suggests a similarity to beads on a rosary, that is why it is called as Paternoster, and the lakes are often connected to one another via a stream. For example, we have a kind of valley like a structure is there. So here you will have one lake, then from this lake you'll have a stream that will be emanating out. Again we have another lake, and again we have the stream that is emanating out. Again we'll have the other lake. So if you look at this ridge, what it seems like, it seems like rosary beads which are connected by the strings, where rosary beads are the lakes and the string here is the river streams. So these generally are formed in the low depression of a U-shaped valley. Generally what happens when glacier is moving in these valleys, they have carved out the U-shaped valleys. Now when the warming occurs, the melting of glacier will happen, and here and there where the depression is more deeper, water will get accumulated, while in the slightly upper areas we'll have the river stream that will flowing through the upper part of the lake to the lower part of the lake. And that is why we can see this is a very famous picturesque Paternoster lakes that has developed again in the US and Canada, in the Alaska range of Canada. So that is how Paternoster Lake develops. Then as the glacial keeps on moving in the downslope direction, it leads to formation of what we refer as roche mutinis. Roche mutinis develop due to the erosion of the erosion by the glacier when it is moving from the downslope region to the upslope, from the leeward side to the other side, and thus it seems like a streamlined asymmetrical hillock. Why we are calling it asymmetrical? Because from this side it seems the slope is very gentle, and this is the side from which glacier is moving, and then on the other side the steepness of the slope become very steeper, and thus it have a asymmetrical slope. That is what we can call as Rochimutini. So glacier is moving from this area and then finally it is descending on the other side. The most characteristic feature of Ruche Mutinis is that one side of this structure is smooth, very polished in nature and have gentle slope, while the other side is much more steepened and craggy in nature. The reason behind this is very simple. The area from which the glacier is moving first, that is the directional movement of the ice, here we see smoothing due to the process of abrasion. On the other hand, when glacier descends on the other side, it gets involved in what we can call as plucking, and due to the plucking of rocks we have this kind of rugged kind of edge that develops here. So this is also something you'll see large number of rochemutinis in the lower part of the glaciers. This is one of the left out rochemutinis. As you can see, the glacier must have moved from this particular region, so you can see this side is very smoother in nature, and then suddenly when the glacier descends on this side, we can see it has very steeper slope, and you can see a rugged kind of edge, rugged kind of face. Then we have another important landform that can be called as fjords. Fjords are considered as glacial trough. Trough is a deep depression, steep valleys, and which are occupied by the water from the sea or seawater. These are also characterized by steep sided walls and also have several hanging valleys here and there. The floors of these fjords are below sea level. This is most important point about the fjords, and thus they are always inundated with the ocean water. The fjords are most commonly found in countries such as Norway, Greenland, as well as New Zealand. So, if we try to understand how fjords might have developed, we can look at this particular picture here. Suppose, for example, this area was a mountain and valley kind of structure. Now, during the ice age, what happened? The entire area was covered by, as you can see, thick sheet of the ice, thick sheet of the glaciers. Now, again, when Earth entered into the phase of warming, we'll see the retreat of the glacier. And as glaciers start to retreat in the backward direction, what happens? The erosion that has been caused by the movement of glaciers, the backward movement of glaciers, this causes formation of deep valleys in this rock bed, in this bottom structure. And thus, as glacier retreats more and more away from this region, and the sea level will obviously rise because Earth is in the warming phase, and thus we'll have the melting of the snow, and the seawater rises. And as seawater gradually rises, the ice sheet is continuously moving away, ice sheet is continuously retreating, and thus the valleys that has been formed by the ice sheets when it was advancing towards sea, they are filled up by seawater, and that is why we have a valley that is filled up by seawater, which we refer as fjords. This you can see is one of the most notable fjords in the Norway, which is also included in the UNESCO biodiversity World Heritage Site. And as you can see, on both sides of this fjord we have steep sloping mountains, and this was a valley that can be considered as a glaciated valley, which has been occupied by the seawater because the sea level is higher than the depth of valley. So that is how fjord development occurs. So overall, if you look at the structure, if you look at the major glaciated landform, which we have discussed till now, the most important is glacial trough, which is a U-shaped valleys. Then we have hanging valleys, as you can see from here. We have lakes that can be called as storm lakes. We have the waterfall that can be used for development of hydroelectricity, generation of hydroelectricity. Then we have Arêtes, that is the serrated ridges, which is separating two different cirques or Corries. Then we have horns, that is because of the backward advancement, or we can say backward erosion of glacier from the three sides. Then we have Paternoster lakes, which you can see a series of lakes that develops in the glaciated valleys, which is connected by a flowing water streams. And then we have the Cirques, as we have discussed. So these are the all important erosional landform as far as the glacial landforms are concerned. If you like the video, please hit the like button, share it with your fellow aspirants, as well as subscribe to our channel for more such helpful content. Thank you very much.